Good afternoon, everybody, and thank you for joining us for this webinar. This webinar is being co-sponsored by NERC, the Northeast Recycling Council, and NEMOA, the Northeast Waste Management Officials Association. And of course, we'll be talking about C&D materials and markets in the Northeast. I'm Lynn Rubenstein, the Executive Director of NERC, and I'll be moderating today's webinar. We are recording the webinar, and it will be available on both the NERC and NEMOA websites in the near future. Construction and demolition materials are generated in new construction, remodeling, deconstruction, and demolition. As you know, there is an increased emphasis on the processing and reuse of C&D materials. Many of them can be recycled and made into new products. For example, clean, untreated wood can be made into new wood products, such as furniture or wood chips for mulch or landscaping. To address these issues are Jennifer Griffith from NEMOA and Natalie Starr and Ted Siegler from DSM Environmental. Jennifer is going to be speaking first, but I'm going to do everybody's bios right now. So Jennifer is a project manager at NEMOA. She is responsible for a number of solid waste projects, including training and research. She also manages a variety of initiatives, including those focused on construction and demolition waste, municipal solid waste, disaster debris, and beneficial use determinations. Jennifer has a master's in technology and policy from the Massachusetts Institute of Technology. Prior to joining NEMOA, she worked as a consultant at firms involved with landfill design and waste site investigation and cleanup. She will discuss results of NEMOA's recent released analysis of data collected by the environmental agencies in Connecticut, Maine, Massachusetts, New Hampshire, New Jersey, New York, Rhode Island, and Vermont on architectural C&D materials generation and processing. Following her presentation, Natalie Starr and Ted Siegler from DSM Environmental will present the results of a Massachusetts Department of Environmental Protection funded study that evaluated the current and future status of construction and demolition debris in Massachusetts. Natalie has spent over 25 years in the solid waste, resource recovery, and energy field. Her work is focused on improving the economics of solid waste management and recycling programs throughout the U.S., as well as in Central Europe, South Africa, and Argentina. Natalie specializes in benchmarking and economic analysis of recycling systems, including urban and rural collection systems. She has been involved in analysis, design, and contracting of recycling and refuse collection systems throughout the Northeast, focusing on increasing recovery rates and efficiency. Ted is a resource economist with 40 years of solid waste management experience, working for the states of Maryland, Nevada, and Vermont, and since 1987 as a partner at DSM Environmental Services. Over the past 25 years, he has specialized in waste characterization and recovery rate analysis and improving the efficiency of recycling, collection, and processing systems. He has also worked in 14 countries around the world, focusing on municipal finance, infrastructure improvement, and full cost accounting for solid waste management, and is currently involved in efforts to quantify the amount of land-based plastic waste entering the global marine environment. Before the presentations begin, I'd like to remind you that everyone is on mute, but that we really do want your questions. So in order to do that, please use the chat or questions feature on the GoToWebinar dashboard to ask your questions. So that dashboard is either showing up at this moment on the upper right of your screen, or there's a little orange arrow that is pointing to the left, and you just click on that and it will point to the right, and it will show you the question box. And you just type those in, and at the end of both presentations, I will read the questions, and we will be answering as many as possible. So with that, Jennifer, I'd like to turn it over to you. Thank you.
Great. Well, thanks, Lynn. As she mentioned, I'm going to be presenting the results of the report that NEMOA recently published, titled Construction and Demolition Materials Management in the Northeast in 2013. Before I talk about the data, I have a few things just to put the report in context. So we did focus on materials from building construction, renovation, and demolition. So with processors of C&D, we tried to focus on those that take in mixed C&D materials, and not, there are facilities that handle mainly asphalt, brick, and concrete from road and bridge projects. We try not to include those facilities because the data would dwarf the tonnages, and you would lose the picture of what's happening from building construction, renovation, and demolition. Likewise, there are facilities that handle mainly land clearing wood, and also we tried to not include data from those facilities. The report covers, talks about disposal, landfill uses, and recovery. We published a report on 2006 data previously, and the new study presents the 2013 data and makes some comparisons with the 2006 data. And I just want to reiterate again that landfill uses are not considered recovery. We report them separately because they're not technically considered disposals by all the states either. And landfill uses are for shaping and grading, roads that are in the landfills, and also alternative daily cover. The report focuses on the 8 NEMOA states, which are Connecticut, Maine, Massachusetts, New Hampshire, New Jersey, New York, Rhode Island, and Vermont. The report covers data that is from facilities that report to states. So so it's not necessarily comprehensive looking at all possible C&D, because if it goes directly from a job site to for recycling, that type of data is not collected by the states, and so we don't know about that. And again, the data is for 2013, and that is because we started trying to collect data from states back in 2015, but state resources are limited, and so we were not successful in getting all the 2013 data until more recently. And also NEMOA resources are limited as well. So, and a final thing to note is just that the states themselves do not direct or control the management of C&D materials in any way. Really, it is decision-making in the private sector that determines where these materials go and what is done with them. The states do, regulate the facilities and how they operate, but they don't direct the construction companies as to what they do with the material. So first, we're going to focus on disposal data for C&D. And this is the information that we collected from the states, looking at C&D that is generated in the state and disposed of. So that includes exports. The black here, if you can see my pointer, the cursor, is looking at material that's disposed at facilities within the state where it's generated. The gray is where they're exporting material to facilities in other NEMOA states, and the white is exports to non-NEMOA states. So where are those states? So primarily, Connecticut is sending their material to Massachusetts, New York, and Ohio. Massachusetts is sending its material to Maine, New Hampshire, and off to Ohio. New Jersey and New York, both facilities in those states, send a lot of material to facilities in Ohio and Pennsylvania. And then Vermont facilities send their material to the neighboring states of New Hampshire and New York. And again, we're looking at, this is the picture in 2013. So what are the changes from the 2006 data? So overall, much less material was sent for disposal in 2013 from Connecticut, Maine, Massachusetts, and Vermont. Connecticut exports to the so these are some particularly interesting things to point out, is Connecticut exports to non-NEMOA states were about half of what they were in 2006. Massachusetts exports to NEMOA states, so other states within NEMOA, were about 2/3 less. And both Maine and Vermont experienced less disposal of in-state generated material. There was also less disposal occurring in New Hampshire, and that was mostly reductions in disposal of in-state generated material. About the same amount of material was disposed of by facilities in New Jersey, but the mix of where it went changed. So in-state disposal increased from 2006, and exports to non-NEMOA states decreased. And then generally, there was a little bit more disposal of C&D that occurred of what was generated in New York and Rhode Island. And that was mostly due to increases in in-state disposal. Now, if we look at it a different way, this is material disposed at facilities within a state. So it includes the imports to the state. It doesn't look at exports. So again, black is what's disposed at facilities within the state where it's generated, and the gray here is exports to non-NMOA states. To other NMOA states, imports from other NMOA states. And then it's not shown because New York's tonnages are so significant, we wouldn't see any of this detail if I put all of New York's data on the graph. But they do import quite a bit from non-NMOA. Actually, it's a province, which is Ontario. So quite a bit of some facilities in New York are not too far from population centers in Ontario. So Maine is mostly importing from Massachusetts, and same with New Hampshire, but Massachusetts gets imports for disposal from Connecticut, and as well as New York. What changed since 2006? Disposal facilities in Maine, Massachusetts, New Jersey, and Vermont disposed of about half the amount of material that they did in 2006. So Maine particularly had a lot less imports from out of state, and also less of their in-state material. And the reductions in disposal at facilities in Massachusetts, New Jersey, and Vermont was mostly due to reductions from their own in-state material. Disposal was down in New Hampshire as well, but by about 25% instead of 50%, and that's mostly due to their in-state generated material. And disposal in New York and Rhode Island was up some, mainly due to, again, in-state generated material. Some notes on disposal. Generally, data is all from the disposal facilities, so you can't just take all the data that, say, Massachusetts supplies me about what they exported. I look at what the disposal facilities in those importing states say they got from Massachusetts. So we generally use disposal facility data. I also do look at Ohio and Pennsylvania, and the data in Pennsylvania is considered of high quality and usable. In Ohio, generally, they just report things as solid waste, and it doesn't really distinguish which type of waste. So it's not possible to use data directly from Ohio. Out-of-state imports might be missed a little bit on disposal numbers, because if waste comes into, say, a processing facility in a state before it's disposed of, the disposal facility will record the data as being from the state where the processing facility is, not necessarily, where it all gets muddled together, and it's not possible to kind of separate out what comes from which state when it's passed through several facilities. So we might be missing some material on the origin of it. And lastly, Connecticut, most of the processed C&D debris, so the facilities that process C&D, they report, it's reported as it's exported for disposal, but some of it could be being used for landfill uses instead of disposal, but it's all reported as disposal. So now we'll look at some processing, and we're going to look at the high level, so just inputs to processors. Again, black is in-state generated material that went into processing facilities, and gray is imports from NMOA states, and none of the states imported material from non-NMOA regions, the processors of C&D. So how does this, do these figures compare with 2006? Oh, where are they imported from? So the gray material, where is it imported from? basically Massachusetts. Maine, New Hampshire, Rhode Island, and Connecticut, all the processors, the material that they get from out of state is from Massachusetts, and in Connecticut, some of it does come from New York as well. Here's the changes from 2006. Less was processed in 2013, and by pretty significant quantities here. They're highlighted here, the reductions. Slightly more was processed by facilities in Maine and Rhode Island. They both took less of their own sort of in-state generated material in 2013 compared to 2006, but they, both of those states, the facilities in them imported more. And like we said, like I said just a minute ago, it was from Massachusetts. Now we're going to look just at the general categories of outputs from processors. So we have disposal, that's in the black. We have landfill uses, that's in the gray. And the amount that's actually recovered for reuse and recycling is sort of checkerboard. So you can get a feel for the mix of material that processors are generating. And like I said earlier, Connecticut, they report it all as being disposed, but perhaps some of it is landfill uses, so we don't know exactly the mix for Connecticut, but the amount recovered is the checkerboard. So changes from 2006 in disposal. Things to highlight are just processors in Connecticut and Massachusetts sent quite a bit less for disposal in 2006. Landfill uses. More was sent from processors in Maine, New Hampshire, and Rhode Island in 2013, and significantly more from processors in Maine. So, looking here at the numbers. So in 2006, processors in Maine sent about 38,000 tons for landfill uses, and that was up to 137,000 tons in 2013. And in Massachusetts, there was a significant reduction in the quantity of material that processors sent for landfill uses. It's actually greater than 350,000 tons less. It was reduced from about 585,000 tons to 210,000 tons in 2013. So in recovery, again, processors recovered less tonnage in 2013 than they did in 2006 in Maine, New Hampshire, and New York. There were similar tonnages recovered in Connecticut and Rhode Island, and Massachusetts was the only state, and we'll hear more about what's going on in Massachusetts from the next presentation, but they were the only group of processing facilities that actually recovered higher tonnage than they did in 2006 by 195,000 tons more, and they also recovered a higher percentage of the incoming material. A few notes on processing data. Double counting, I tried to eliminate that as much as I could because if a transfer station or a processor is transferring to another processor, that material would get counted twice as incoming material. So I eliminated that when I could see it. New Jersey, you might have noted on the graphs, there isn't data for New Jersey about processing, and that's because they have recycling facilities, but they don't distinguish the source of the material, and therefore the data that they have, it's sort of all combined. You can't tell what is from construction projects. You know, the metal might be from recycling of other municipal waste, so we don't include New Jersey. In New York, the data includes all the C&D material processors. That includes those that are doing sort of the road and bridge work. New York is a large state, so there's a lot of facilities, and there's a lot of large facilities, but to the extent possible, I tried to remove the ones that appeared to be only dealing with the asphalt, brick, and concrete, or the land clearing debris, but some of that might still be in this New York data. Rhode Island noted that the largest C&D processing facility in that state may not be providing the most accurate data. So there's a little bit of uncertainty on the Rhode Island data. And then in 2013, Vermont did not have any C&D processors. They also didn't have any in 2006. But in, I think, 2014, a couple came online in Vermont, and I believe now they have 3 in the state of Vermont. So, but unfortunately, because we're looking at 2013, we're missing all that activity.
Jennifer,
yeah?
This is Lynn. Couple of quick questions. One person has asked, could you please, while you were on this notes processing slide, this person said, could you please go back to the processing slide? So I think probably, not sure which one they meant. But then while you're doing that, there was a question of what is the difference between disposal and landfill uses?
Well, disposal is where the material is just disposed of. So I guess they're paying for disposal, and it's just being like any other waste that's going in the landfill and being covered up. And landfill uses would be when generally they get a break on the price that they have to pay at the landfill, and the landfill is using it as the cover material, the alternative daily cover, or in shaping and grading if they're, if they're needing to close a cell in the landfill and they need to get it up to grade. Sometimes they'll put a lot of C&D material in there to do the shaping and the grading. So there are uses at the landfill, but there's some states don't consider that, recovery and recycling. It's a diversion from disposal, but it's not true recovery. Other states feel like, well, it's ending up in a landfill, it's disposal, but a compromise is to report it separately when we can.
And we know that some of these states also have waste to energy facilities. When you talk about disposal, is it only in landfills, or are you including waste to energy facilities?
We are including waste to energy facilities when it's reported that way. So one of the data nuances in this study was that, Connecticut knew material from their processors was going to Massachusetts for disposal, but it was going to a waste to energy facility. Now, Massachusetts, the waste to energy facilities are allowed to accept C&D material after it's been processed, but they don't really have a separate way to report that. So it was just getting reported as MSW that they were accepting, or other material, a more general category. So it wasn't noted in the disposal data that I got from Massachusetts, but because Connecticut, knew that the disposition, it was included. So yes, where the data is reported as being C&D and from waste to energy facilities, yes.
Great, thank you. So I'm hopeful that you've had this slide up for a long time. So maybe slowly just advance to, because the person commented they just hadn't had a chance to focus. So you could go back to recovery. Thank you, Jennifer.
Okay. So this is general categories of outputs. Now we will move through and look at what the recovered outputs are. So we're looking at the categories of asphalt shingles, aggregates, those asphalt, brick, and concrete, the gypsum drywall, wood, which is both clean, quote unquote, and the C&D wood, and metal. And like I've mentioned before, facilities that really only deal with the aggregates, we tried to remove, but facilities that take in mixed C&D do generate some, aggregate waste, because they do get that kind of material coming in, and they also get, they can get some clean wood, they can get pallets, they can get new construction wood, they can get maybe some yard material, so they do get some clean wood as well. So the mixed C&D processors also generate these types of materials, and that's what's being reported. But we're trying again to not be including facilities that dealt just with those materials. So I'll leave this one up for a little while, and maybe I'll just look through my notes and talk about this instead of showing you the slides. So I'll just talk about the changes from 2006 while we're looking at this slide. I think that's probably was a better strategy for the other one as well. Sorry about that. So asphalt shingles are the only material that is this top bar here, the white, the total clear white, is asphalt shingles, and that was the only material that was recovered at a greater tonnage in 2013 than it was in 2006. Back in 2006, the state of Maine was the only state that reported recovering asphalt shingles for reuse or recycling. And but in 2013, recovery was occurring in Connecticut, in Massachusetts, in New Hampshire, in addition to Maine. So that was the only material that has greater recovery. Aggregates are not really reported by facilities in Maine, so we don't have any comparisons there. Connecticut and Massachusetts, the tonnages are up from 2006, and in New York, they're down, and in Maine, they're similar. And Rhode Island,
so Jennifer,
I guess, as well.
Yes? One person asked, what are ABC aggregates?
Asphalt, brick, and concrete. So, generally they grind it up and it becomes a new aggregate that's used for fill, mostly, I think. I'm not sure. Maybe some facilities actually segregate it by brick, by concrete, and so maybe it can be utilized differently. But generally it would just be a fill material. I think Natalie and Ted in the next presentation can probably know a little bit more about the fate of some of these materials than perhaps I do. Gypsum wallboard, the tonnages that were recovered are relatively small, but still they were up in Connecticut and Massachusetts compared to 2006, and the New York amount was less, and the Maine is similar to what was reported in 2006. Looking at the clean wood, which is this sort of dotted number here, I think. The clean wood amounts were up in Maine, Massachusetts, and Rhode Island compared to 2006, and they were less recovery in Connecticut and New York than in 2006. Lastly, well, not lastly, but next, metal. Massachusetts and Rhode Island were recovered more than they did, facilities recovered more than they did in 2006, and there was less recovery reported in Connecticut, New Hampshire, and New York. Now, that might be because metal prices were pretty high in 2013, and projects were diverting it more directly themselves. We're not really sure the reasons for that. And then if we look at the C&D wood, I'm highlighting this separately because I think we'll hear a lot more about wood from Natalie and Ted in a few minutes. But there was significant decreases in the amount of C&D wood that was recovered for mainly for fuel use or for use in other manufacturing by Maine, New Hampshire, New York, and Rhode Island, all significantly less these tonnages than they were in 2006. But Massachusetts, this tonnage is significantly increased. Back in 2006, it was only about 21,000 tons, and here in 2013, it's almost 130,000 tons. So Massachusetts facilities, Massachusetts has done a lot of work with C&D, the C&D sector, and trying to promote recycling and processing, and I think the data is showing the results of that. So, onto my slides that showed the up and down, which people will have for a reference after this webinar, and the tonnage decreases that I just discussed. So just to wrap up here for myself, I just want to again highlight that we did a report on 2006 data that was published in 2009. That report has state-specific sections. It was a more comprehensive report. NMOA had greater resources at that time. We estimated generation and discussed markets. And the key findings in the report on 2006 data was that overall, basically across all the states, about 10% of what was generated was recovered in 2006. So in some states, the majority of C&D debris is processed, but then following the processing back in 2006, 90%, was still ending up as alternative daily cover or disposal landfill uses. And in other states, they might have looked at their processors thinking, oh, they're recovering, 50% of what's coming in or 60%. However, there's in those states, a lot of the generation maybe was going directly for disposal, so that the processors are, more discriminatory on what they took in. And so they're processing a higher percentage for recovery, but there's still quite a bit going directly for disposal. So overall, the 10% recovery was across all the states in 2006. I hope that made sense. And the other key finding was that, back in 2006 and probably holding through today, metal's the only material that's really recovered at a high percentage of its generation, which was about 53% back in 2006. And again, that's just through the facilities that are reporting to the state. NMOA's done a few other things regarding C&D. We undertook a process after the 2006 data report was published. Part of the issue there was that, states aren't collecting the same information from facilities. They're not using the same terms. We undertook an effort to try to bring some consistency there, but I think it was really implemented in New Hampshire, but not necessarily by all the other states. So we still had some issues with this 2013 data. We also really focused on gypsum wallboard back in 2010. We focused on sort of what policy options states might be able to implement to increase recovery of gypsum wallboard, and came up with these 5 here. Bans on disposal, requiring recycling on state-financed projects, require waste management planning by, construction projects or demolition projects, improve the data to improve transparency, and extended producer responsibility for wallboard. And we have a couple other related activities to construction. One is a beneficial use determination database, which includes like landfill uses of C&D debris. It's a database of beneficial use determinations. It's not exhausted, and we haven't had funding to support it for a few years now, so it's not necessarily up to date. But one thing that we do currently still do is looking at soil reuse and the management of that sort of mildly contaminated soil, some of that excess soil from projects, construction projects. We have a work group that's got both the solid waste and the waste cleanup folks in the states. It's a forum to share information, and we have published on the NMOA website sort of a information resource where the different policies and things states are doing is located in one place for all of our 8 NMOA states. And here's the slide about what NMOA is, which, if people don't know, we're a nonprofit, nonpartisan interstate association, includes the solid waste programs in each of the states. We were formally recognized by EPA in 1986, and that's our website where you can find the report that I talked about today, and the report on 2006 data, and the policy recommendations, and the soil reuse information. And here's my contact information. So I think with that, I am wrapped up, and we'll turn it over to Ted and Natalie at DSM.
Great. Jennifer, that was incredibly impressive. Thank you so much. A lot of information. And just to give you a heads up that there are a lot of extremely interesting questions for you. So to encourage the audience to keep those questions coming using the question box in the dashboard, and we'll get to them at the end of the presentations. So at this time, I'm going to turn it over to DSM, and I believe that Natalie is going to kick us off. And we're just waiting, Natalie, for your PowerPoint to open up for us. And you're going to put it in slideshow, and we're just about perfect. Great. And Natalie, why don't you say hello so we know we hear you? We don't hear you. I wonder if you're on mute.
So hopefully we can see the screen now. DSM
There you go.
is going to talk
Thanks, Natalie. Take it away.
a little bit about the opportunities and challenges with managing C&D, focusing on the Northeast and Massachusetts. I just want to start with a little overview on generation, and thank you, Jennifer, for all that background. I don't have all the numbers from the individual states, but I have looked at quite a few numbers. I want to just go over some of the challenges with coming up with good numbers. Certainly, there's very wide fluctuations with estimating C&D generation and disposal compared with municipal solid waste, which is more homogeneous. Certainly, there's fluctuations in MSW based on the economy, as there is with C&D, but we also have natural disasters that are impacting our C&D waste generation rates. Disposal also is more challenging to track. It's more dispersed for C&D than it is for MSW and less regulated. Picture you see is one of the natural disasters down in the islands down south. This is becoming more and more common and is going to become a continuing challenge in terms of how we manage C&D. I also want to talk about generation and disposal, because you certainly can't manage what you don't measure, and every state is a little different. I looked just generally at nationally, US EPA estimates 166 million tons of building debris. This is 2014. That excludes the asphalt and concrete from roads and bridges and other communication, power, transportation projects. Anyway, this 166 million tons compares against the 169 million tons of MSW left for disposal after recovery. So my point being is that C&D may be a lot more than we think, and we often think about it, I often do, as some small percentage compared to MSW, but it really can add up, particularly in years where we have a good economy, we have a lot of building, new construction and demolition, and then adding with those natural disasters. If you take it on a per capita basis, 3 data points from states that I did have data, Mass DEP tracked a little over 1 million tons, which ended up being 0.17. Connecticut tracked 0.29 tons in 2013. This is a Green Seal report, some good information there. And Delaware tracked 0.24 tons in 2014. So these are all in the ballpark of one another, but depends on what you're tracking. This should all track building debris, but it's easy to have higher or lower numbers depending on how much ABC waste is included in that and whether or not you've had natural disasters and other types of waste included in the C&D. If you use those numbers, using the high of 0.29 tons per capita and looking at our 10 NERC states, we can have generation estimated at about 18 million if you assume recycling is about 15%. I use 30 for Mass because that's a number I'm more familiar with. What do we have left to manage? Maybe 15 million tons. Now, this is high compared to what you just heard from NUMOA, but it gives us an idea of how much C&D waste we might be dealing with in terms of thinking about capacity. So when is most C&D generated? This is a slide done by EPA from one of their reports. It's good to think about when you think about how you're going to recover different materials. And looking at this slide, drywall and plasters are the one material you really want to go after during construction. also asphalt shingles, but most of these materials, most of them are generated during demolition. And so they come in mixed loads, making it harder to recover and needing separation technology. So what are some of the things that have been done to reduce C&D waste disposal so far? We have some states with material bans, some states with processing requirements. We have lots of goals for diversion. We have LEED certification and green building requirements leading builders to materials. And finally, economic incentives. The renewable energy credits for the biomass facilities create the demand for B wood or a slightly lower quality wood versus the A wood, the higher quality wood that might go into higher uses. Subsidies for MRFs for C&D, market development grants, and then also rising tip fees for disposal, and any sort of surcharges on disposal or something that might drive recovery. Some of the states that have implemented bans, Vermont having a ban on clean wood disposal recently, also on recycling of architectural materials, if the project is of a certain size and if you're within 20 miles of a facility that recycles this waste. Massachusetts has a diversion goal of 50%, but the rate's plateaued around 30%. They also require C&D be processed before its disposal in a mass facility. That processing is to remove recyclable materials, and they have bans on certain materials. Asphalt, pavement, brick, concrete, metal, and wood were banned over a decade ago. The goal with this ban was to support the development of in-state processing facilities and to preserve disposal capacity in the state, and also to achieve their goals. So I'm going to go into Mass in more detail, going through a case study and where we looked at the impact of their processing requirements and looked at what we could do to try and increase recovery. And then I'm going to turn it over to Ted, and he's going to talk about the markets. The project we did was last year, and we looked at what were the constraints to increasing diversion beyond their plateauing 30% goal. What are the opportunities? We did look also at their initial progress after these bans in 2008. And so you can look at both reports. I think they're on Mass DEP website, and see some of the differences. We also tracked regional markets through this. A big part of our scope of work was to go to the facilities themselves and look at incoming and outgoing loads, what was in them, what was being recovered, and what were the opportunities to increase recovery. We spent a lot of time looking at material flow from their annual reports, which are really quite detailed in Massachusetts about what they recover, where it goes. We looked at new technologies that might increase recovery. We looked at the market specs currently, and this was last year, and the barriers to increasing diversion. And DSM has spent a lot of time looking at C&D waste over the years in many of the NERC states, as well as in Ohio. And looked at the composition of it, and certainly C&D waste is every load is a little different. We also calculated the recycling rate. Roughly 25% of the mixed C&D loads that were coming and being processed in the state of Massachusetts was recovered for recycling in 2015. Also, some material came in already separated, adding another 86,000 tons to that. So you might say the recycling rate's 32% if you only counted the C&D waste that was managed in the state. Some of the waste went directly to processing facilities out of state, and the processing or recovery rate at those facilities is unknown. So out-of-state processing that generates recyclables isn't really included in their rate. Next slide. So this is just a pie chart that shows where material went in 2015 in Massachusetts based on the annual reports. 23% was disposed straight out. 24% went to landfill-dependent uses. That might be daily cover, it might be cell construction, it might be road construction. 16% was processed, went through the processing line and was recycled. 6% came in source separated. That might be metal, wood, pallet loads, or even asphalt shingles. 13% was transferred out of state, and then 18% really was bulky waste and was not C&D waste. And this is important because this material often gets classified as C&D or comes into a facility and is harder to manage and has fewer recycling opportunities. So what can be done to increase recovery? We also spent time doing visual analysis. So instead of doing waste characterization, where you actually separate and weigh materials, we do a very detailed visual analysis where we look at the volume of materials coming in, we get the weight of the load, and then we determine the density of those materials and come up with a percentage of each load by weight that is each material. So this conversion to weight-based composition helps to tell us how much we have of each material. Here's just a picture of a bulky waste load. So this came into a Massachusetts C&D processing facility and isn't a good load to go over their C&D line. So what were our results? This is for the material that was C&D, not the bulky waste. As you can see, 79% were straight construction demolition materials, 2% paper, 2% plastic, and so on. And 2% MSW bag. There's always those loads of C&D that come in and they have several bags of MSW in them, and or people use them as an MSW dumpster while the building project is underway. So what's that 79%? What does it look like? Well, wood is roughly 39–40% of incoming C&D. Certainly that's a material targeted heavily by processors for recovery. And that's everything that's shaded in green. The other materials, asphalt roofing and clean gypsum board, certainly targeted, as well as metals. Overall, the materials that can be recovered of a C&D load are roughly, I think it's roughly 55% if you add the paper and the plastics and the organic material that might come in to these C&D materials that could be recovered. So you're already starting with a material in which you have the potential to recover a little more than half of it. We also compared what we saw in the field in 2016 to what we found in the literature when we did the study in 2007-08. While we did go and visit all these new facilities, we didn't do the visual analysis that we did in 2016. So we used the literature to kind of estimate C&D composition. That being said, some of the differences might be that the literature had more concrete and rubble in it, slightly less wood, and slightly less plastics. Plastics certainly were almost 10% of what we saw in the field. So what we tried to do, and understand this is limited data, but this is important, is try and come up with a recovery rate for these materials that we're targeting. Where are they at now, and how much more recovery might they get? And in Massachusetts, both processors who have a processing line, just like a MRF sorting line, and transfer stations receive C&D. Some of these transfer stations do not have processing lines. But they did, a couple of them participated in the study, and overall, the recovery rate of the processors were roughly 48%, and transfer stations were much lower because they didn't have this equipment. As you can see, cardboard, about 30%, 22% overall. Metal, ABC waste, very high. They tried to recover all the metal they could. Asphalt roofing, quite low. That's because once it comes into a processing facility, it's usually mixed with other materials. They try and pull it aside manually. If it goes over the line, it's much harder to recover that material. Clean gypsum board, also hard to recover once it's mixed in with another load. They pull it off manually before they go on the line because it just simply breaks up. And Ted will talk a little bit more about the markets for these materials and what they demand. And then wood, a little over 30% at 32%. So I'm going to turn it over to Ted now, who's going to talk about these materials more specifically and what the markets looked like last year.
Okay, thanks, Natalie. This slide here gives you an indication of the sales of the material that were processed in Massachusetts so that you have an understanding of where materials went in terms of material category. And it's no big surprise, and you'll see this again, we'll talk more about this, that wood is the largest single material that is being sold from the C&D processors in Massachusetts. although there's a fair amount of asphalt, brick, and concrete. It's very heavy material. They recover almost all of it on the line. Metals, as Natalie said, quite high recovery rates. Plastics and gypsum, OCC, and other materials, much lower sales volumes and much lower revenue. Wood is really the largest revenue source as well, except for metals. So I'm going to start with wood because it is so important for the processors. And there's really a couple markets for wood waste. And the first one is wood waste combustion. Basically, dry C&D wood has probably at least double the BTU value of green wood chips. And therefore, if you substitute it at a wood combustion facility, you get high energy values, but there are a significant number of environmental and operational issues associated with burning the demolition wood waste when compared to green wood in terms of contaminants, nails, and other contaminants, and in terms of fines, and therefore worries about heavy metals emissions. There was a really robust market for wood waste combustion in 2007. Almost all of it out of Maine, so virtually all of the waste wood that was being separated from Massachusetts processors was going to Maine facilities. The two primary users were Sappi, which is a paper mill near Portland, has the capacity to burn waste wood, but doesn't purchase very much from Massachusetts. And Borlax, which is now Reenergy, at the time was running, in 2007, was running 3 wood-fired boilers that were around Maine that were accepting wood waste. But they all stopped accepting the wood waste due to Connecticut ruling concerning renewable energy credits. They've been essentially selling the energy to Connecticut utilities who were able to take advantage of the renewable energy credits, but the state legislature or regulators stopped that. And so as a consequence, they stopped burning the waste wood, although we've heard that some of those facilities may be accepting waste wood again, primarily from Maine C&D processors. The other major wood waste combustion facility is in Connecticut, and that's Plainfield Renewable Energy, which is a gasification facility. They also purchase waste wood. We understand, because we don't have direct data from Plainfield Renewable Energy, but we understand from processors in Massachusetts that are selling some material to PRE, that PRE has kind of operational and storage constraints and quite tight specifications, especially for fines associated with their gasification process. The largest use of waste wood, somewhat surprisingly, is for particle board. There is the largest particle board manufacturer, I think, in the world, certainly in North America, is Tefisa, located up in Lac-Mégantic, Quebec. You probably all remember that name from the horrendous train wreck up there that destroyed most of the town. But they are still the largest buyer of waste wood from New England. They collect that material. They essentially send their own trucks to the wood waste processors and pay for the wood waste and then truck it up to Quebec. They consumed 216,000 tons in 2016, of which 60% was sourced from Massachusetts and New Hampshire. They would like to increase consumption of waste wood, but fines remain a problem. Just like for waste wood combustion, trace metals have been reduced at Tefisa, reducing the amount of fines that Tefisa can accept in the wood that they get from the waste wood processors. So that means that the processors are having to screen a larger amount of fines out of the wood chips that they're sending to Tefisa. And one of the reasons that Tefisa has tightened its fine standard, in addition to the fact that they are worried about heavy metals in the products that they produce, is that Quebec has tightened their combustion specifications, resulting in tighter specifications for burning waste wood. And Tefisa no longer has an arrangement with Kruger to take the fines that Tefisa was separating, and therefore they've tightened their specification. The fines market definitely continues to be a major problem. If you remember back in 2006, 2007, a lot of the fines were being used as alternative daily cover at landfills throughout New England. and we started to have significant air emissions issues from those landfills, and that has not changed. That's still an issue, and so almost all of the landfills have stopped accepting fines as an alternative daily cover, although you can mix the fines in with regular MSW and not have the same emissions issues. But as a consequence, there really is no market for fines, and the waste wood processors, or the C&D processors, are having to increase the amount of fines that they're separating from their wood chips in order to make sure that they can sell the wood chips. And there's really no way to eliminate fines if you're dumping the C&D, mixed C&D on the floor at a processing facility, and then you're using size reduction. In 2006, most of the processors were grinding C&D before they manually separated it on the lines. They stopped grinding, and almost all of them now use an excavator on the pile to break the C&D into manageable size pieces, perhaps a foot to 2 to 3 feet in size, and then that material is then getting pulled off the lines. But all of that dumping on the floor, running over it with an excavator, and then grinding the recovered wood after you've separated it out, all creates fines, and that's an inevitable part of the processing. So what are some of the other materials that you can recover from the mixed C&D? We see in all the visual analysis we've done around the United States of C&D loads, every load that comes in, if you were to look at it from a volume point of view, is probably somewhere in the order of 5 to 15% corrugated. And if it's the end of the construction for a new construction, house or business, it's probably going to be 30 or 40% corrugated, because all of the light fixtures, plumbing, supplies, countertops, refrigerators, everything is coming in a corrugated box. So there is a fair amount of corrugated. The problem with the corrugated that's coming in mixed C&D loads is that it typically is contaminated by the other C&D materials, and because most of it is stored in open top 30-yard roll-offs, if it's wet, it's wet. So as a consequence, it's being pulled off at the C&D processors, but it has lower value than it would have at a nice, dry, single-stream MRF facility. And many of the processors don't have baling capacity for OCC, so they're selling it loose. So it's a relatively low value, but it's worth pulling off. The other area that is clearly beneficial to all of the C&D processors is to pull off metal, both the kind of framing metal like the picture you see here, but also there's been more interest in all of the wire that is being pulled out in demolition loads. And the question is there a way to remove this wire, especially if it's not magnetic and if it's tangled with other materials? So there's interest in developing eddy current separators to pull this material off. It's high value if they can pull it out, copper and other valuable materials. But there are problems associated with pulling it out. So the material that you see, metal material that you see that is not being recovered from C&D processors, is primarily wire and other non-metallic metals, where most of the metal that it can respond to a magnet is being pulled out. Plastics, no surprise, like everywhere else, plastics are a larger and larger fraction of what we're seeing in C&D, although we can't directly compare 2006, 2007 to 2016 because we didn't do visuals in 2006. We have been doing visuals for the state of Delaware on and off over the last 10 to 15 years, and the amount of plastic that you see in the mixed C&D loads continues to increase. And there has been a market for the big bulky plastics. Most of it is polyethylene or polypropylene, but those markets were primarily export markets. And as with everything else, with the Chinese import restrictions, the value of that mixed bulky plastic has fallen significantly. The other problem with bulky rigid plastics is that the majority of it is 5-gallon pails or other containers. And while it has some value, most of those 5-gallon pails are contaminated with paint or gypsum drywall compound or glues or other materials, significantly reducing their value. The other significant amount of plastic is plastic film, both blue tarps and clear plastic, shrink wrap, and it has potentially value, especially the clear plastic film, but with plastic film, just as it is for plastic film generated in residential and other commercial activities, it has a high surface to volume area, so there's lots of potential for contamination. It's sitting in an open top container, it's being dumped on by C&D materials, so it's difficult from a contamination point, and it's also difficult to pull the film off the picking lines because the excavators aren't doing a very good job of ripping it, so it tends to be long pieces of film that can be wrapped around other materials. We're still waiting on gypsum markets. Yes, you can take new gypsum and recycle it back into new gypsum, but there aren't any gypsum recycling facilities in Massachusetts or in New England primarily that are doing that because it's relatively inexpensive to use power plant, air pollution control, gypsum materials to produce new gypsum. And so as a consequence, the value isn't very high. It's also difficult to recycle painted and wallpaper gypsum. So most of the gypsum that is being recycled is new gypsum from new construction sites. And the best way to handle that is to keep it separate at the construction site, not mix it together with mixed C&D, because as you can imagine, as it makes its way through a mixed C&D facility, it shatters into smaller and smaller pieces and becomes more and more difficult to recover. Asphalt shingles, most asphalt roofing recycling is delivered directly to facilities and end markets. It doesn't end up going through the mixed C&D processing facilities. And so as a consequence, we don't have very good numbers for asphalt shingles per se. There is a market in Massachusetts, Kearney's and Rainham, and there are other markets, smaller markets in Massachusetts and New Hampshire for asphalt shingles. So if it's a clean load of asphalt shingles, and many times if you look at a roofing job, it's probably 90% asphalt shingles and another 10% wood or metals coming off of that. If the roofing company can find a market for that material, given how heavy it is, they're going to use that market as opposed to bringing it to a C&D processing facility and paying a tipping fee for it. And I think part of the issue here is that there's a real need for the states to continue to press departments of transportation to increase the allowance for asphalt shingles in new asphalt. So what are some processing advancements and target materials? Again, as Natalie pointed out, even though we have a relatively high recovery rate for waste wood from Massachusetts processors, there are additional wood that could be recovered, but it depends on the ease of separation from contaminants, especially pressure-treated wood, and difficulty in meeting the fines definition. So one solution might be to install additional equipment to recover this wood for sale to Tefisa or to a biomass combustion facility, and states could assist with capital costs up front for conveyors, air separators, disc screens, optical sorters. They're all being used now for in these processing facilities. And another potentially encouraging development is that if we could optically identify pressure-treated wood on the processing line, then we would probably be able to pull a lot more waste wood off. What happens now is that pressure-treated wood, which has is not allowed for combustion or for in Tefisa's products, as a consequence, if you're not sure and you're manually separating material on a conveyor line, anything looks like pressure-treated wood, then you're going to throw it away. If you could positively identify pressure-treated wood using optical sensors, then you could leave more of the waste wood on the line and just pull off pressure-treated wood. So we see that as potentially an area where you could increase recovery of wood waste by having a better way to identify pressure-treated wood. Other potential markets, one of the things that Massachusetts was really interested in was whether you could use small-scale gasification units to convert the fines and bee wood into energy. And so we did look in detail at that, but essentially our conclusion was wasn't really feasible for the following reasons. Primarily, if you were going to use it for energy, you would use it on site, and the processors really don't need heat. What they need is electric power for equipment. Biogas that's produced needs an internal combustion engine to convert it to electricity, but the biogas that contains a lot of tars and impurities that are difficult to fuel a combustion engine without extensive cleanup. And when you add that cleanup equipment, it's just simply more expensive than buying conventional gasoline or diesel fuel or even natural gas to produce electricity. And so while gasification has always been promising, and the PRE facility in Connecticut is an example of a gasification unit that is using C&D waste, the PRE facility has struggled for the last 5 years in terms of dealing with the issues associated with gasification of wood waste, and that's a big facility designed specifically for it. Finding ability to use small quantities of the material at individual processors is significantly more daunting. And as I talked about earlier, metals are another area where there's some room for improvement, not necessarily in terms of a large increase in the recycling rate, because most of the heavy metal is being pulled out already, but because the metals that are remaining, such as copper in metal sheathing or metal wiring, is relatively valuable to the extent that we can add eddy current separators and other ways to pull these smaller quantities of more valuable metals off. That may be another way to increase the recovery from these processors. So what are some of the takeaways? Basically, given the markets, processors in Massachusetts are doing a relatively good job of recovering materials from mixed C&D waste. They're currently recovering roughly 50% of the marketable materials, resulting in a 32% recycling rate for C&D waste managed in Massachusetts. We expect that that's substantially higher than most other states in the Northeast. And that's despite the fact that the market for wood waste is much more limited now than it was in 2007. Greater recovery really requires continued investment in new processing equipment at existing processing facilities, and also implementation of processing equipment at the transfer stations, which are handling a lower value C&D material than the material going to processing facilities. But low tip fees make it difficult for processors to justify running low value C&D through processing lines and really constrain investment in new capital intensive technologies. The barriers really are the same. Ohio has plenty of cheap disposal capacity, so processing has to stay below rail and tip fee costs to be viable in these states where bans are not in place or enforced. And when we say relatively low, you probably can send tip a load of C&D in Massachusetts or any other state if you're next to a rail line, and transfer it out and dispose of it in Ohio for around $50 a ton. So if you're a processor, you have to figure out a way to run all of your processing equipment and recover enough material and sell it in order to keep your overall tipping fee low enough so that you can compete with that, unless you are only accepting lead generated material where the price of processing can be considerably higher because the builder is trying to meet some kind of environmental standard. But as Natalie pointed out, most C&D waste is created during demolition, not new construction. And while on-site separation creates the highest quality product and recovery rate, there is really limited contribution to diversion from demolition sites as opposed to new C&D sites. And again, just to emphasize again, wood markets are limited and are primarily combustion, but could be boosted in many of the states by renewable energy credits. We always find it ironic, and people from Mass DEP know that I've said this many times. It's ironic that Massachusetts, which bans unprocessed C&D from landfills and has really pushed for processing C&D waste and wood waste, doesn't allow utilities in Massachusetts to claim renewable energy credits for waste wood combustion. So in the end of the day, mass processing requirements have resulted in higher C&D recovery rates than most other states, but RECs are not available in states, so most of the waste would which is the largest material is going out of state to other facilities. And that's my presentation.
Well, Natalie and Ted, thank you so very, very much. Both presentations had not only a massive amount of content, but we have a massive amount of questions. So I'm going to have to cull them down, I'm afraid, but I'm going to ask you to try to contain your responses as much as possible so that we can get in as many as possible. So Jennifer, I'm going to give Natalie and Ted a little break for a second. I'm going to start with you. There were two themes that came up with several questioners, so I'll start with those. There were questions about the impact, if you were able to assess it, of the Massachusetts disposal ban on the Massachusetts export figures that you were reporting.
Okay, can you I'm not quite sure what that question is, sorry.
Well, on your slides, there were impressive numbers of exports from Massachusetts, especially to Ohio, but also other states. So the question was, were the exports impacted, either they went when they were high or when they went down, were they impacted by the disposal ban?
Well, yes. So well, it's hard to know because C&D, like Natalie had said, the generation of C&D is dependent on many things. I think the economy was flying higher in 2006 as well than maybe it was in 2000. It's flying high again now, but in 2013, maybe not quite so much. So it's hard to know whether the reduction in what was shipped for disposal, there was a significant reduction in the amount of material that was disposed of that was generated in Massachusetts between 2006 and 2013, but it's not possible for me to say whether that's totally due to the ban or not, so. Okay.
Well, you started to touch on the other question where we had a number of, in your response, questions about whether when looking at comparing the data, the two periods of time, whether you were able to take into account the economies and the difference of the building industry and renovation industries during those times.
Yeah, no, we didn't. I mean, when we did the 2006 report, on the data on 2006, we tried to look into that, looking at different indicators of economic activity, because we had done a report even before the 2006 data on, I'm not sure, 2002 data maybe, and, trying to see if we could try to look, it was not something that we felt we were qualified to try to do, so.
Now, a couple of questions rose the issue of disaster debris and whether your study had the opportunity to isolate out any of the data as it might have related to disaster debris.
Again, no, we didn't try to see what disasters might have occurred in 2006 or 2013.
So thank you. Now I'm going to switch to Ted and Natalie for a few minutes at least.
Lynn, this is Terry Goldberg. I just want to comment. I don't think the data that the
Terry
states
from NOAA.
Yes. I don't think the states the data collect from the disposal facilities and the processing facilities would distinguish between disaster debris and any other C&D debris. They're just taking in material. So it would be, the states don't require that facilities distinguish between that kind of waste. So, if you might see a spike if there were very big disasters in the years that, we were analyzing data for, and it might account for that. But to say that's, what is disaster debris, C&D, and what isn't, I don't know. It would be hard to make that distinction based on the source of this data.
Okay, thank you. So there were also questions, Ted and Natalie, certainly directed to you, and I don't know if ultimately Jennifer wants to comment as well, about the percentage of material that you were seeing that had been pre-processed. So the information that you were looking at, how much of that had been source separated and pre-processed as opposed to mixed loads?
I don't think that we knew. We were at transfer stations and processing facilities. Certainly, there was a lack of metal in the load. So if you count pre-processing, manual removal of metal at the job site, yes. But pre-processing for any other material, really hard to tell.
Right. We wouldn't have known if a job site had a separate OCC container, for example, or a separate clean wood container. All we were seeing was the material that was coming in for disposal. So we really don't have an answer to that.
Okay. So did you distinguish between construction and demolition streams?
We did, but we have in a number of different studies, and there clearly is a difference between the two streams. In the case of Massachusetts, we did not. We were trying to quantify what was coming in order to do a kind of a mass balance and to try to get recovery rates. We have done that in Delaware twice now with multiple loads. So we do have data that separates what the composition of demolition debris is from new construction. And in Delaware, there are huge differences in terms of what the two waste streams look like. And I think you can go to the Delaware Solid Waste Authority website and probably pull up both the 2007 waste characterization study and the 2015 C&D study that we did in southern Delaware and get that information.
But that's very clear line. There's a lot of renovation which has both, and that's what led us to mix the data in the end. Renovation has often the demolition of some part of a home or building, and then adding a floor or a room or whatever, and depending on what stage they are at the job, you will see a different composition in the load.
Okay. Now, is anyone, to your knowledge, using bioremediation to help in processing fines further to clean materials before then trying to sell them for mulch or other uses?
Not that we're aware of. I mean, we have seen no real movement in the fines market. It's a major problem for all of the processors. I'm not sure how bioremediation would help with trace metals, which seem to be the largest concern for the fines.
And given that even pallets are questionable in the mulch market because of them being treated or what they might have been exposed to, i.e. carrying chemicals, that would be a harder stretch, I think.
Yeah, the mulch market is really a tricky one, especially if you can't control for use of mulch at, say, schools and playgrounds, which is one of the areas where they use mulch. So the people that are selling clean mulch are incredibly careful about what they're putting in there for a whole series of liability issues. And that's not just here. We did a study for Knoxville, Tennessee, with some really big processors down there. Well, no, Knoxville also. And, and in both cases, the mulch market, they were just very careful about what they would put in there. So I would be surprised if anyone was considering fines for that use.
So, so you triggered two other streams of questions that I'm going to get to with that answer. So one question said, what percentage of wood waste goes to mulch? In California, mulch is being sold for $128 a ton and is a higher and better use than burning it.
Well, it certainly is. And if they can recover clean wood, then any of these processors in Massachusetts are going to sell that for mulch. But it is a very small percentage of what we see coming in as mixed C&D to these processors. Our guess is that if you have clean wood, you're probably separating it out at the job site and selling it directly, and being able to tell the mulch producers that this is what it looks like and that it hasn't been contaminated. But once it gets to the processors, there's not a very big market for clean wood. And as Natalie said, even the pallets, we did a big study in Mecklenburg County about pallet use, and the same issues were that we can't even guarantee that a clean-looking pallet wasn't used to store some kind of a chemical that might have contaminated the pallet. So it is a great market if you have really clean wood, but most of what we're seeing kind of at the end of the pipe is not clean wood.
There were a series of questions that related either directly or indirectly to the toxicity of C&D. And so the series of questions started around whether there was information about the average age of C&D. When you see stuff coming through a processing facility, is there a way to age it? The importance being that the age of the debris could be useful for determining likely hazardous characteristics.
Certainly, that's a great thought, but the facilities aren't tagging the loads that way. For lead, I can see maybe they might get into that, but that kind of data isn't being maintained.
Right, and it gets to a couple issues. One is obviously lead paints, which are a major issue. And then the second, asbestos is another one. And then the third one obviously is pressure-treated wood. And as everyone knows, we've gone through various cycles of how we treat wood in order to make it toxic to insects in the ground, and all of those are toxic one way or the other. And in all the cases, we're trying to remove that. But we don't know of any real data on that. There is probably one of the best potential sources of information on that is the University of Florida, which has done a lot of work on characterization of C&D wood from around the United States and has done a lot of literature search. So if you're interested in that, I would suggest that you head in that direction as one possible way to learn that. But certainly we're not capable of defining that. I mean, we can tell if it's in Delaware, if it's a mobile home that's been demolished to put up a brand new house, or if it's in Massachusetts and it's an old building, it's probably quite old and probably has potentially traces of all of those materials in that material.
I think Massachusetts.
So how do landfill bans and recycling incentives address the toxics used in the past?
They don't. I mean, they're basically banning material that can be processed, and the processors are addressing that issue. Essentially, if you look at where the specifications that for waste wood combustion, they were developed pretty carefully by Maine DEP over a long period of time with a lot of input from people in Maine, because there was a lot of concerns over these issues. And then if you look at TEFISA's specification, because TEFISA came into the game after Maine DEP had developed their specifications, and TEFISA's initial goal was to have looser specifications, thinking that they would be able to take a larger percentage of waste wood. But over time, their specifications have become pretty much as tight as the Maine DEP waste combustion or wood waste combustion specifications. And the pre-facility, which is the kind of the newest facility, it's not combustion per se, it's gasification, has even tighter specifications. So in the end of the day, all of the people, all the regulatory agencies have kind of come down to pretty similar specifications for the material that these processors can sell.
Great. We're running out of time, so two questions that I'm hopeful have relatively short answers. Some of the asphalt shingle processors have indicated quality issues with recycled content in new asphalt. They mainly use it in road base. Is this prevalent in other parts of the Northeast?
I think that is primarily the issue, is that they use it in road base. But I think that a number of people on the call who have been involved in environmental agencies around the country will readily admit that dealing with departments of transportation who have a different set of priorities compared to reuse and recycling will say that it's frustrating, and it's quite difficult to get departments of transportation to relax their specification and allow additional materials to be included, such as waste plastic for different materials and waste asphalt shingles. I think that the issue still needs more work, and there's a real need for communication between the two agencies.
And Mass DEP did do some number of testing, I do recall, on asphalt shingles, trying to determine whether or not to ban them. So there is some data there.
Great. And final question, although I want to thank our audience. There are some amazing questions that have been presented that we have not addressed. We'll see how we might be able to compile them, and some of them I think I know about resources I can point you to, and we'll just see what we can do. So final question, has aluminum from structural materials become fire hazards at any recovery sites due to sparks from sorting?
We haven't seen that, but I think people in the processing industry, it's not aluminum that's the big worry. It's lithium batteries, which are a major problem at the single stream MRFs, and are probably also a major problem at C&D processing facilities, much more so than aluminum. There are lots of spark hazards at these C&D facilities. They do have fires. They have good fire suppression equipment. A number of them have added kind of increased recently infrared cameras and other ways to detect hot spots. So just given the dust that they generate and the materials that they're processing, fire hazard is always a concern at these facilities. It's not just from aluminum, it's from a lot of other materials. I mean, they can get in a gas can that is mostly empty and not see it, and they can get lithium batteries that sit in the waste pile that they don't see and overheat and cause fires. So lots of potential for fire damage at C&D processors.
And they would like to see more aluminum because of the value in it, and they often doesn't make its way to the facility in the first place.
So now I wish I picked a more upbeat question to end on, but since I didn't, I want to say to Jennifer Griffith from NMOA and to Natalie Starr and Ted Siegler for DSM Environmental, great presentations and wonderful conversation in the question and answer period. Thank you to all of you, and especially to our attendees. As a reminder, this has been recorded, and I will be posting the recording as well as both of the PowerPoint presentations on the NERC website, as I'm sure NMOA will be as well. And you'll be able to find that announcement for that in the February NERC email bulletin, which I think that most of you are subscribers to. So again, thank you everybody, and really appreciate your being here. And with that, we'll say good afternoon and goodbye. Bye-bye, everybody.
Bye, Lynn. Thank you.
You're welcome.
Thanks, everyone.